This is the module developed for simulation-based solution approach for resilient supply chain networks for retail. First, select the model under the File menu to load the model. Under Model Data, we can see 6 tables, 3 under the category of Master Data, namely Sites, Products and Demand, and 3 under the Policy category, Sourcing Policy, Transportation Policy and Inventory Policy. Inside the Sites table, first we have to remove all the filters. We have a total of 25 sites, 10 of them serving as collecting points as S1, 5 of them serving as milling stations as S2, 3 of them as regional distribution centers as RDCs, and finally 7 distribution centers acting as customers. Next, inside the products table, we have product carrying a value of 30 and price of 50. Under the demand table, we have the quantities demanded from each of the distribution center in the network. Next, under the sourcing policy table, we have S1 tiers marked as make stations, while all other facilities source under the policy multiple sources, most inventory. These are the columns sourcing policy table has. Under the transportation table, we have all the possible connections a node can have. Connecting RDC to the RDC, S2 to the S1 and RDC to the S2. Under inventory table, S1, S2 and RDC are listed and follows the inventory policy of RQ. They all have a reorder point, a reorder quantity, and initial inventory. We have included initial inventory in such a way that it won't trigger an order in the start of the simulation. Basically, we have included a number higher than the reorder point so that it won't trigger and order. Under the visual modeler and the map, we can visualize the network. First, let's open the visual modeler. Here we can see how all the nodes connect to one another. And in the map shows the location of each site. DCs in magenta, RDCs in purple, milling stations in dark green, and collecting points in light green. When we take the line 1, all the possible connections are shown between the nodes. Some nodes are connected to only one and some are connected to few, representing the variation levels of strength in each of the node. Now let's start the simulation. Models and scenarios are listed here. Baseline, S1 disruption, S2 disruption, and RDC disruption. Now let's see what are those scenarios are. S1 disruption is where we exclude two nodes at S1 level, and S2 disruption is where S2 and RDC disruptions are where we exclude one node from each respective tier level. Resuming with the simulation. Simulation is set for a period of 1 month. Which is shown in the model data here. And then let's run the simulation for all the scenarios. Solver monitor simulation status shows for what days the simulation is running and the current status of the simulation. And it also shows the graphical movements in the map. And the scenario shows the current scenario that is simulating and the ID. Once the simulation is finished, a window pops up saying it is completed. And the records in the simulation queue, model queue, shows as completed. Going back to the map to see the results, select the simulation view and the scenarios under the scenario tab. In the baseline scenario, we can see that some of the milling stations and collecting points are not used to fulfill the demand requirement. In S1, scenario shows that Bandaragam and Beragala nodes are excluded from the network and had attached to different nodes to fill the requirement from the DCs. S2 disruption exclude the Buttala milling from the system, and the system sustains against the disruption with the existing network while fulfilling the demand requirements. Final model RDC disruptions when the Mathura RDC is removed from the network. Remaining RDCs were able to fulfill the demand requirement of all the distribution centers. Under the simulation summary graph, we can show that the profit table network has been able to perform regardless of the disruption. Thank you for watching.